libraries, modules and packages. So today we'll start with this section, modules and packages. Okay. Now, whenever we are doing programming, right, it should be reusable, right? It's not like, yeah, we write a program, throw it away, tomorrow we have to do the same thing, we start writing all over again. Or you have written one big program, it can be used only for the purpose that you have written. It should not be like that, right? Normally we do things which can be reused. The same is the case for programming as well. So there's a principle called as DRY, do not repeat yourself. One application of this principle we have already seen when we have written functions, right? Functions are like you write a group of statements, you attach a name to them which suggests that what those group of statements are going to achieve. Accordingly, wherever you need that functionality, for example, like configuring a device, all the statements which are required, specifically what type of configuration you want to do, right? So all the statements which will achieve that purpose, you can group them into one function so that wherever such configuration is required, you can simply call this function without having to write this code again and again. Okay. Now, an extension of this concept is libraries and modules, right? It's like we have been using the third-party libraries provided by someone else, correct? Like, what was that? What did we do? Did we use anything yet? All these things, in fact, right? The print, the type, all those functions have been written by someone. Same way. Okay. So, yeah, where was I? Yeah. So modules are like any Python code that we write becomes a module, right? That is the kind of reusability or modularity that Python offers. When I say it's a module, it can be reused. It can be it can be used in some other code. Package is a special directory, special directory structure, which can be used to package, as the name suggests, right? Group multiple modules, multiple related modules, so that it can be easy to export it to third-party websites as your own library, right? In case you want to read, right? You will write a bunch of modules which are nothing but Python files, and then package them into folder using a special way. You create a package. Right. Now, package is nothing but any directory with a _init_dot_py file. You just place this. This can be a blank. This file can be blank. You simply place this file in a normal directory. It becomes Python treats it separately as a package. Now, package is just a logical structure which is used by Python internally. But modules are the ones which are your actual Python code which can be reused. Okay, so we'll see one such example. Okay. Suppose I have a bunch of config commands, which we'll be using to send it to the network devices in probably the next session using NetMiko. I just have a, what is this? What is this data type? It's a Python list, right? List of strings. In this case, it contains strings, so it's a Python list, right? So I have a list of commands, and then I have a function which just displays the list, which loops over this function accepts a list, then it uses for loop to loop over the commands and then prints them. Okay? So I'm not doing anything in this as such. I've not written any other logic. I just have defined this data and a function. Now I'll write another function. In this, I'll say import my module. Okay? Now, because my module is in the same directory, it is able to identify it. Even otherwise, if it is somewhere else, there's a specific path in which this Python looks for these modules. Okay? Let me show you that before I get there. So there's also a list, a group of paths. So when we try to import some package, right? It first looks for that package. Right now, what is module? What is module again? Module is any Python file which contains some code. It could be data, it could be functions, it could be commands, it can be anything. Right? Any regular Python file that you can write will become a module. Now that module can be used in some other place by importing it. Now when you try to import it, first it will try to look for that module in the current folder. If it does not find it in the current folder, these are the location it tries to look for, right? Like see, this is my current folder. Right? This is my current folder. So first it tries to look for in this. If it does not find, it goes to userlib, the Python zip file, which is available in userlib. Then this folder, then this folder, then this folder. So in all these folders, it tries to look for the name that I'm trying to import. If it does not find in any of these, it throws an error saying, I can't find that file. Right? So we need to keep this in mind when we are trying to import something so that we'll get such errors, then we'll know where to place your modules. So in this case, it is there in the current directory itself, current folder itself, it is able to identify. So I can say import my module. Now, what is the benefit of importing my module is whatever I've put in this my module are available to me now in this via this name. So when I say my module dot, right, I see these two, which have been defined in the other file, and conf commands list as well as show conf commands function. Okay. So I'll be able to call that function. Okay. That is the advantage of module. Now you can put anything that you need. So typical usage of modules is, let's say we are writing, we are automating some task, right? Network task or something, where we'll be reading data from files. So we need to store them in Python objects like dictionaries, lists. Right? So we create one Python file specifically for storing this data, which has been extracted from files, so that it is available at one central location and your data is not scattered all over the project files. Right? So you keep one folder like modules and place all your commonly used, which the data which is going to be shared, the code which is going to be shared, put it in that location so that that can be imported and used in any other code that you will be writing. Yeah, so list. Python script saved as file can be used as module in another script as import. Yes, it can be. Right, we just saw that, right? I just have a normal Python file. I imported it in another this thing. Okay. Now, suppose I have this function call here. I'm calling the function here itself, right? So that this is like a normal. I've defined a list. I've written a function. I'm executing it. Now, if I suppose I'm writing this, I just imported my module. I've not invoked anything. I'll run my module tester, the file which is importing that module. Right? The code already gets executed because in the module which you are importing, there is this data function as well as the command which executes. So this got executed as soon as you imported this module. So we should not have this kind of commands in the modules, which we plan to use them in other places. Otherwise, you'll keep if you make such mistakes, right? You'll keep wondering why that function is being called twice. Once it is being called from here, the second time it will be called from here. which will lead to some inconsistent results. Here it is just a print statement, so that is fine. But if it is doing something significant like deleting some objects or creating new objects, then it could lead to certain inconsistencies. So in modules, you should just have either data or certain functionality, certain functions which you intend to use. Okay, so that's about module. Now, you see, I just said import my module. Right? Everything that I have defined in my module is available to me. The function, the list, right? Now, in this case, there are only two. Suppose I had 100, 200, 300. As soon as I said import my module, all of them will be made available to me, and which is like a waste of your precious computing resources. So if you know that you are not going to use everything from the base module, you're going to use only certain limited functionality, then this is a not recommended way of importing module. Right? Instead, what we can do is we'll say from my module import whatever you want. Okay, from module name import. Now, when you type like this and then hit Control Spacebar, it will show you what are available in this module. Accordingly, you can pick. Then only this will be available, right? Only this will be available and not the data. Another advantage with this is, now you see here I said import my module. So whenever I'm referring to the functions or data from the other file or the module, I will have to prefix those with the module name. So wherever I'm using them, I'll have to keep calling my module dot show conf commands, my module dot conf commands, and so on. Here I'm saying from this module, you directly import this function so that I can call this function as it is. Okay, without having to subscribe with this. Okay, so this is second way. First way is directly import everything. Second way is this. Now let's say I'm too lazy to type all this show conf commands, though it is recommended. Right? You see people usually name the Python objects, methods in a very elaborate manner so that they don't, it is intuitive. It suggests what they're trying to do. Right? But for some reason, let's say I'm lazy, I just want to give a short name. And I can give a short alias from my module import show conf commands as show. Or I can simply call show so this is third way of importing. So if your module is small, you don't know what you'll be needing, or even if your module is big, you don't know what you'll be needing, then you simply import it. But if you know what exactly you'll be needing, then you pick and choose from this module, import something. Let's say these names are too big, or they're conflicting with some names that you are trying to use in your code. And then give aliases. Give them short names, which are like aliases, so that you can use those resources with this name. Okay, that is about this thing. Now suppose, how do I make this as a package? Is simply create a blank file and name it __init __ dot py. Right? Now you won't you won't feel any difference, but Python treats this as a separate package. Now, where you will feel difference is, let's say I pull my module tester into outside. I'll create a package inside my package, push this guy and this guy. Okay, what I've done is I've created one folder called as my package. Inside this, I've created a blank file called as double_ini_.py, which tells my Python that this should be treated differently than a normal directory. It should be treated as Python package. Then I've placed my module in this. Now, what's the advantage of packages is, let's say you're a multi-vendor library, right? Like NetMiko, you're a multi-vendor library which can work with multiple devices. You put all Cisco related code into one package, all Arista related code into one package. So you can neatly segregate your code. Okay, that is the advantage of packages. Okay, and my module tester is outside. So now here, if I have to import this thing and then use them, I'll say from my package, put a dot, you will see what are the modules in it. My module, put a dot. What to import. Okay, this is the only difference. Now you can prefix your module with a package name, so that there's suppose two different packages contain similar modules with the same name, right? Then there's no confusion which package you are importing this module from, right? So that you are giving a fully qualified name. Okay, that's all about Python modules and packages. So to reiterate, any Python code that you write will become a module. And if you have written it smartly without having these commands which actually execute the code, you can reuse it wherever you like. And when you want to package multiple such modules into related components, you can use the concept of packages. Right? Now, inside this, I can also have sub-packages. Right? The subfolders under this will become sub-packages. So that within a package, if I again have a logical separation, I'll place them into sub-packages. In that case, the importing will be from package dot subpackage and whatever level, dot subpackage, and so on. Right? Finally, import module. From that module, import whatever you need. Right? Now, I can also say import my module dot my package dot my module, which will import the complete module. Any questions? Yeah. So we'll see one built-in module called as JSON, which will help us to work with JSON data. Right? Now, to be able to use work with this JSON data, we first have to import, right? So that's the difference between, for example, like I'm using print function, right? I don't have to import anything because print, type, these are all part of the core library, Python's core. Right? Whereas these things like CSV, JSON, these kind of packages, they come with the installation. When you download Python, they come with it, but they're not available as they are. They are not part of the core. So you will have to specifically import them to be able to use them. Right? Now, I don't know what all data types, what all methods are available in JSON. What I'll do, I'll simply say import JSON. Right? Now, what is there in this? You can check using a command called as dir directory. Right? Dir of JSON. So it shows some errors which are thrown, decoder, encoder. Right? JSON is like a special format. So to deal with JSON files, you need to, sometimes you'll have to decode, encode the into the file format. And then there's double underscore stuff or like internal stuff. And then there are some functions like dump, dump s, load, load s. Right? As the name suggests, dump, dump s. Right? Dump is like we are trying to dump JSON something as a JSON string. Right? Now, what is closest to JSON in Python? What looks like JSON data in Python? It is dictionary. Right? So if you have a Python dictionary variable, you can straight away dump it into JSON string. Right? Now this dump is used to dump it into a file. Dump s is used to dump it into a string. Same way, the opposite of dump and dump s are load and load s. Suppose you have a string variable. You have a string which contains the JSON-like text that can straight away be read into Python dictionary using this load s method. Load s means load from string. Let's say, as we are going to see in the next section, we'll be dealing with files. You have a JSON file. Then you can load that JSON file, which contains the JSON data, which is contained in the JSON file, into Python dictionary object using the load function. Okay, so these are the main important functions. Right. So I have a dictionary. This is a Python dictionary. Okay. How do you know this is a Python dictionary? We'll print its type. This is like chaining of functions, right? You can chain any number of functions. First I'm calling type function on this variable. So this will give me what data type this this variable is. Now that has to be printed. So I take this entire thing, right? I take this entire thing and pass it to print function. Okay. This is like saving some storage, saving some space, and saving some time. Right? Ideally, what we will do is we'll create a variable like data type is equal to call this function on this data type. So this will return what type of data it is. Store it in a variable and then use that variable to print it. So instead of having this intermediary step, which is not achieving anything other than wasting a variable, I'll directly take this and use it for print. Right? So whenever we are creating variables, we should ask, okay, am I going to use this variable elsewhere, or it is just for one-time usage that I'm creating this? If you see that yes, you're creating a variable just for using it once, you try to avoid creating that. Of course, in the programming that we are going to do, these things really do not matter. But in serious programming, these small things add up to a lot of performance issues. Okay, it is dictionary. It is of type dictionary. And now I'll convert this into a JSON string. Right? I'll call this as device facts underscore str, denoting that it is a string. How will I convert? I'll use dump s. Right? JSON dot dump s. What to dump into string? This Python variable. In the string, as well as try to print its type so that we'll know it is in fact converted into a string. Okay, I have a Python dictionary. I'm checking what type of data it is, confirming that it is in fact dictionary. I'll comment this line. Then using the JSON.dumpS function, I'm dumping this dictionary into a string, printing that string as well as checking its type. Right, initially, now it is converted into a string and its type turns out to be string. Now, how do I know that this string is? Now, this is a dictionary, right? From dictionary, let's say I want to extract host name. Okay? I can extract like this. Print or host underscore name is equal to device facts of, and this is the key. So using the indexing notation, I pass the key to get its value. Same thing you try to do with this string. It will throw an error, obviously, because this kind of operation is not defined on the string. Okay. It says string indices must be integers. You cannot use this kind of indexing on string. Now, what is the advantage? What's the advantage is this process is called as serialization, right? Which means you have data in memory, you serialize it into a series of bytes. You convert it into a group of bytes so that the group of bytes can be written to a file, written to a database, written to a persistent storage location. Later, the load and load s, right, are used to deserialize, which means take the serialized this thing and to deserialize and store them back into the program as variables so that you can work with them as if like it's your data available in variables. And some technical terms. When you are taking Python variables, writing them into string or file, the process is called serialization. And when you are doing the reverse, taking data from string or file and loading it into your program, that's called a deserialization. Okay. Now, you might not have found this as very useful, but you will see its power when we see the load part of it. Right? So let me comment this. Now, I have a string like this. Right? Where did it come from? Probably I called a API. Right? API has typically your REST APIs return JSON data. Right? Let's say I invoked an API either here in Python environment or in other tools like Postman. You get JSON data. Now you have your JSON data, JSON underscore string. It is like this. Obviously, because this is a string, I cannot extract. Let's say I want to extract host name, this value. Right? Obviously, I cannot use the dictionary notation, Python dictionary notation. It won't work because this is a string. So what I'll do, I'll convert this into JSON object or dictionary object. Using JSON dot load s. What to load? Load the string. Now you print this dictionary object. Print its type. And try to extract hostname from that. Print of okay. This string, JSON string, has been converted into dictionary object by this load s function. It has taken a string, it has loaded JSON data from this string. So that's why we call this as load s. It is loaded and stored in this variable. I'm printing that, gets printed, its type is DICT, and now I can use this as like my Python dictionary. Using this kind of index notation, I can extract any data from it, which I can't do with the string. Of course, I can do if I'm very good with the string operations, but that will be like very hectic and very non-Pythonic way of doing things, right? Python gives some very simplified things to achieve some things, and if people are not using them and doing in a very primitive methods, crude methods, so we normally call them as this is non-Pythonic way of doing it, right? So that's about modules and packages and how we can work with one very important built-in module called as, library called. Library is nothing but like can be treated as a collection of packages. Package again is a collection of modules. Modules are nothing but Python files. Okay, so I keep using these terms interchangeably, so do not get confused. Right. Typically, any third-party code that we borrow, like this JSON, we call it as library, third-party libraries. Third-party libraries are nothing but group of packages. Packages are nothing but group of modules. Modules are nothing but Python code. Okay, let's move on. Working with files, right? Now, so far what we have done is we have either hard-coded this data, right? We have hard-coded this data into in variables in the code itself, or we have taken this input from user using that input method, right? But these are not very practical ways of getting the data into your program, right? Because typically you get this data from, let's say, REST APIs, you get from files and so on, right? REST APIs dump the data into files. Those files are given to you. You are supposed to read the data from them and then do some processing with that. And so that's why Python supports an extensive file operations working with different types of files. Now, what Python can work with is all these files. We call them as flat files. Right? Flat files means all text files. Right? The extensions can slightly vary. Like for example, .txt. Right? You can have .log file which contains text, right? .conf file which contains text. But ultimately, all this .log, .conf, .txt can be opened using a text editor. So all these will be treated as text files or flat files without any internal complicated structure. Same way JSON files, they end with .json. They look in a different, in a specific structure, but they are ultimately flat files. Same way, CSV files, comma separated values, right? Those are also like your text files, right? Flat files. Of course, CSV holds a slight distinction that it can be, because of the nature of its structure, it can be opened using your Excel program, Microsoft Excel. But that doesn't that doesn't make it any more complicated than what it is, which is like a plain text file, right? Also, all these files that we are dealing with, they are called as flat files. Now, using normal, simple libraries, all these flat files, we can work with them. And the other thing of the other end of flat files are like your custom files, like your Microsoft Word, PPT, PDF, Excel, right? So those things are not straight away supported out of the box, but to a certain extent, to a good extent, Excel support is there in the form of some other libraries. Some other special libraries have to be downloaded and imported. Then you can work with Excel files, right? Now this support is given because Python is very popular for data science. In data science, data excessively comes from Excel files. So the support was required. So the package which supports this is called as Pandas. Right? You must have heard about it. Pandas can make your life easier when you are dealing with reading huge amount of data from Excel files, writing data, and so on. But we are not talking about Pandas now. We are talking about simple libraries which will make your life simple by providing file operations, file input output. So first we will see how to read and write text files. Suppose I have a text file like this, which consists of my some config commands. Okay. At its simplest level, I can just use the command called as open to open my file. Right. Now, if I simply execute this, the file will be opened and it's lost. right? It will be opened, but we can't do anything with that because we lost the handle to deal with that. Okay, so we should store that. When we open the file, it returns something called as a file handle. And we should store that in some variable so that we can use that file handle to perform some operations. Let me call it as conf file. Right? I'm opening a file. This will return me something called as a file handle, which is like a Python object. I'm storing it in this. So if you want to see how it looks, print it out. If you want to know how this variable looks, what data is there in that, simply print it out. Okay, it looks like this. Right? It is internally there's a object called as text IO wrapper. So it has written an object where its name is conf.txt. It is showing me something called as mode. Right? This mode is whether it's whether you want to read or write. Right? These are the two modes that that you also have append. Right? So read, write, or append. These are the three modes that files can be in. And what is the encoding? This is the character encoding. Right? So this is how an opened file looks like. Right? Now, I've not specified that I want to read from this file. I've not specified this anywhere. But still, it is being opened in here because default mode of operation is read. Default mode for files is read. So if I simply say open, Python will understand that, okay, you're opening it for reading. So unlike normal files, right? Normal files, when you are dealing with the files, you open the file, you read the data from it, you also type the data. Right? When you are dealing with, like, say, text files or any other files. But Python is very wants to be very safe. So it strictly wants to prevent people from manipulating data or accidentally overwriting the data. So it enforces these things. If you want to read the data, you have to open the file in a read mode. If you want to write the data, you have to, though that file is already open in read mode, you have to open it again in write mode. Right? So that's the way Python works. Now, what is there in this file? I have some methods. Right? I open the file, I got my file handle, I'm saying read. Right? Now this will return me some data. Right? So I'll store in a variable. File data is equal to confile.read. I'll print out this data and see. No surprises there. Whatever we have put in this text file is just coming. But this entire thing is coming at once because I just said read. Right? Read the entire data. So it read this entire data as a string and it returned this string. So you can do whatever you want with that string. But let's say this is not very useful for me. I want to, now I can't take all this and then give it to the network device, right? It will get confused. So I want to get line by line and then give it to my, let's say, network command network device. Right? So instead of this, I'll use read lines. Let's say I just want to read one line. I'll call read line. It just read the first line. Now pointer is at the first line. Again, I put these statements. It read the second line. So whenever some data is read, there is a pointer, there's a file pointer which keeps track till which point the data has been read in this current session in which the file is opened. So in the first line, first read line, read the first line. So the pointer is pointing to the second line. The second read line read the second line, and so on. Okay. Suppose I had, by mistake, I had read all the data. Right? I had put this statement somewhere and I forgot about it. Then I realized, okay, I don't need to read the entire data at once. I want to read line by line, and I put this statement like this. Let's see what turns out. Nothing. Right? Now, what is happening is this guy, this read guy, has read the entire data into this variable. Now, I'm not printing that variable. That's why you don't see anything. But then when this read line tries to read from this, there's no data in it. It has already been read using this read method, which means the file pointer has already reached the bottom of the file. So there's no contents at the bottom of the file. That's why this is written in blank, and this is written in blank, and everything else after this will return blank. So what they have done is, in such cases, like you read it once and then you want to read it again, you have something, they have given you one method called as seek, using which you can reset the pointer, reset the file pointer to whichever location you want. Right? So this read method read my entire data. Now pointer is at the bottom of the file. Right? What I'm saying is, when I say read, it starts from here. En is read, then conf t is read, then this is read, then this is read, then this is read, and now your pointer is at this location. So at this location, if I say read line, there is nothing here to be read. So what we have to do is, we have to use a method called as seek and supply some location within the file to send the pointer back to that. I'll say seek 0. Seek the position 0 in the file, which means the pointer will be moved back here, so that we are as if we have never read the data. When it says read line, this data will be read. Okay, so here we will put seek 0. Of course, I'll have to call with the file pointer. File pointer dot seek 0. Seek 0th position within this file, which means send the pointer back to 0th position. Right? Now this emptied the data, but this put it back in, took the pointer back. So these two lines are able to read it. Okay. Now, there is also another useful way, because we know how versatile Python lists are. We like to work with Python lists. So to make our life easier, there is one more method called as read lines, which will return the data as a list. File lines is equal to confile dot read lines. Now you print file lines. What you get is a list. If you want to print this just like your data, use for loop to traverse. For line in file lines. Print line. This blank line is coming because it has inserted this thing at the end, a new line at the end. That's okay. You can always use some string methods to get rid of these things. Okay. Now, how do you write data to a new file? Just the opposite of it, right? You want to open a file. Specify that you want to open in write mode. Now you traverse in a loop for line in conf lines new file dot write, the opposite of read. Line. We get back our data. Things to remember? Nothing much. Okay. Only thing is the modes. When you want to read, unless you give W here, you'll not be able to write. It will throw an error. Right? And if you open it like this with write, you'll not be able to read from it. I think write also allows you to read also. Let's check. Yeah, not readable. Excuse me. Okay. Now, one thing that we have not done here is we have done so many file operations, like we have opened some files for reading, for writing, right? Proper way of coding best practices, whenever you are dealing with this kind of like file handles, database connections, right? After you open them, perform the operation, you are supposed to close them, right? Otherwise, there'll be so many file handles dangling in memory, and these dangling file handles pose security threats. So if you are familiar with security testing, VAPT, right, vulnerability assessment penetration testing, one of the checks it does is, are there any dangling file handles? And because hackers could use these file handles to attack your system. So a proper way for after this would be new file dot close. So this will ensure that the file is closed and your file handle is destroyed. Yes, we can do that. Read write. Okay. Now, after all, we are human beings, so we keep forgetting this kind of nice little things. So what Python has done is it has introduced one guy who can do this for us. Right? He is called as a context manager, right? Who maintains the context. So once we are out of the context, it automatically you open a file, you open a file via the context manager, you get into the context, you are done with the file operations, come out of the context manager will take care of destroying the closing the file and destroying the file handling. Right? Now that context manager is can be invoked in your code using with keyword. Right? So we'll say with open count.txt as input underscore file. And this is the file handling. Earlier, it was returning a variable which I was storing in it was returning a file handle which I was storing in. Here, the with will ensure that you can give a name to it. When it opens the file, you can give a name to the file handle. So this with guy is your context manager. With open this file as input file. You're calling this as input file because you are reading it for, you're opening this file for reading. What you want to do? File data is equal to file handle dot read lines, whatever methods that you have seen, you can call them. What happened to my data? So that's the context manager. You will see this in many places being used because this has become the best practice. Right? Whenever we are dealing with file objects, it's better to this will be used in many other situations, like when you are establishing connection to your network devices, working with databases, all those things. You'll be using this context manager, so that it keeps track of what is happening within this context. Once you come out, right, once you come out of this context, the file will be automatically closed. Is there as a variable, but once you exit the program, I think that will be gone. File handle will be there. I think file status we can check. Input. Is it doesn't matter. Is open. Is yeah. File.closed is true, which means the file has been closed. And I put the same statement here. Here it is false, which means the file is still open. Once it's out, it is closed. Okay, so that's about the same thing you can do for write as well, right? Just by opening it in write mode. So that's about text files. Now, let's say you have so another important format we just saw is JSON files. Right? Yeah, we have covered pretty much everything. Okay, CSV file. Let's take the CSV file first. CSV file looks like this, right? Comma separated values. Right? So name, comma, column attribute 1, comma, attribute 2 or field. And so this is like header row, and what follows are all data rows. Right? So this is the device for which this is the IP address. So first column, first value will be associated with first column. First row of first value of first row will be associated with this. This will be associated with this. This is the second row of data. So this is like tabular column, right? Like your database table or your Excel sheet. So that's why this is this can be opened by your Excel. Right? Neatly, it comes in this rows and columns. But though it can be opened in this, it is like a plain text file. I can open it using my Notepad++, which is like a plain text editor. Okay. Now, to work with this, we need to import something called as CSV, right? A library called as CSV. So we'll use the context manager with open devices.csv as CSV file. CSV dot reader. So reader is the method, but that is available under CSV, and I'm importing CSV, so I'll have to call the reader method using CSV.reader. Now let's check what is this, because whenever you don't know what this will return, right? Of course, when you check its documentation, you will get it, but you get a reader object. So from this, you'll have to again call read and CSV reader. CSV underscore data, CSV underscore reader dot. This itself contains it. Let's check it out. Okay, I need to tell which file I'm reading, right? I need to pass a file handle. My context manager opened my file, stored the reference in this file, then using CSV reader, I'm telling, okay, read the data from this file handle. It's an object, so we'll have to convert it into a list. So my data has been read into the reader kind of object, which is nothing but a list of lists, right? So if you see the data, this is one list. This is read as, each row is read as a list. One list, first list, second list, third list. All three are grouped inside a list. So a list of lists is what is written. That's what we see here. This is the outer list. Inside that you have three lists. There's the first list, there's a second list, there's a third list. So this is the header row, there's the first row, there's the second row. Right. Now you can traverse using for loop and then print line by line, extract some data from it, and so on. You can do all that stuff because it is available to you as a Python data type. Right? Now there's a better way. Now you see, I take this list and then I take this list. Now the connection between them is lost, right? Whether router 1 is device or router 1 is IP, right? I know by looking at the data, right? Router 1 must be device. But the computer doesn't know because there is no association between the header row and the data row. Right? So to maintain this, we can read it in a slightly different way using a special reader, right, called as DICT reader, dict reader. Let me comment this. Opening is the same with open. File name as file handle variable. CSV reader is equal to, instead of calling simple reader, I'll call DICT reader. Okay. Now let me print this CSV reader and see what it throws up. Okay, it has returned me a list of dictionaries, right? You see this dictionary, there are two rows, right? So we got two dictionaries. This dictionary corresponds to first row. Two rows as in two data rows, right? Two data rows, not, right? This is first row of data, this is second row of data. So there are two rows which are returned along with, now router 1 is associated with device. IP address is associated with IP. Switch 1 is associated with device. This is associated with IP. So it maintains the relation between the header row and the rows. So now I can take each of these and process them as Python dictionaries. Right? List of rows for row in list of rows in row. Yeah. Okay. Now the same case is with writer as well. Yes. Just you need to have data, of course. Okay. I have data, which is nothing but a list of dictionaries. I'll be using devices underscore one. I'm writing to a new file, opening it in write mode. I'll be using VICP writer. Okay. Here, what to write? The data. Okay. So some of the data should be passed. Okay, I think this is slightly complicated. Read is fine. Open it with the file handle. So if you have them as a list, right, list of lists, you can write them using normal writer. Write row, keep writing rows. First, you need to write the header row, right? Then you keep writing the data rows. And if you have them as dictionaries, list of dictionaries, first we need to set field names. Field names, and because this mapping needs to be established, right? And then whether to write new line or not. By default, it keeps writing a new line. Dict writer. So file and field names. We write the field names first. We and then write header, write rows. What do you want me to delete? All this data? String, empty string. Neither, because this is all textual data. Okay. For writing, we need to establish the context. So it's first you need to have this data. Then you need to set the field names. Right. In our case, field names are device and IP. This name can be anything. This is just a variable. It's a list. IP. And while opening, right, after opening the file, I say this, then file handle, and then I'll say field names is equal to field name. So I'm telling my dictionary writer what to use as the field name, so that when it encounters this, it'll ignore. It has to ignore this part, take this and write in the new line, right? So for that reason, it needs to know from the data which is coming, which are the names which it needs to treat as fields, the top row. Because first it has to write the header row, and then it has to write the data rows. Right, we have opened it as writer. Right header. It takes this field names as header and writes it. Dot write rows. If I'm getting individual lists, I'll use one by one using write row. Here I'm having a list of dictionaries, so I can directly call write rows, write multiple rows. Okay. Devices one.csv, device comma IP, the same thing. Okay. So again, writing is a little tricky. First, you need to have the data properly this format, right? List of dictionaries. You can have list of lists also, in which case you will use writer object. If you have them as list of dictionaries, you can use DICT writer. Then you need to tell what are the field names. So first store them in a variable and tell dictionary writer what are the which of these strings should be treated as fields. Then first row you write the header. Take the field names and write them as a header. Then you break it, ignore this field name, take the data and write it in the second row. Take this, write it in the third row, and so on. Right? Because it has a bit of work to do, we need to clearly give instructions to it. It's not as simple as just reading and showing the data. Okay. Now, a more useful, of course, all are useful, JSON files. And working with JSON files. Let's say you have, this is your JSON format, right? It starts with a curly brace, then there's the object, the top level object, JSON object. Now the JSON object in this case is a list of multiple objects, right? Each of these curly brace is a JSON object with two values, name and IP. Now you have each of these objects represent a device. So since a collection of them represents a devices, so devices is a list of device JSON objects. So we'll take this. Now this is just a string, though it is a JSON file, it identifies that it is a JSON, it shows in this nice color format. Ultimately, Python will treat this as a string, right? But if you want to deal with it as a variable, you want to be able to extract these values and then use it, we will have to load it. Again, the process is same, import JSON with open JSON as I said, for loading, the operation which makes sense here is load, not dump, right? Dump is for writing into the file. Load is for reading the data from the file. So here we'll use JSON.load and the file handle. That will return me the data. I have to store it in a variable. JSON data is equal to JSON, which is the library, dot load. What to load? The file object. You see the entire data from text, it has been read into a dictionary because of close association between your JSON and Python dictionaries. Now you can deal with this data as you want, right? You can extract the value which is associated with this key called as devices. You get a list. From that list, you extract the first value within the first device, second value, second device, third value, third device, and so on. Right? Let's say I want to get the IP of my firewall. Right? So how will I get it? Print JSON data of devices. This will give me this list. In this list, I need the third object, which means I need to use the index, list index 2. This will give me this dictionary. Now within this dictionary, I want to extract IP address. of IP. So this is a little complex for people new to Python to comprehend why it's like how this complex object can be broken down and then the data can be extracted. Of course, I'm doing it in one line, but what you can do is at each step, keep printing the data, keep checking what type of data it is. Right? For example, JSON data is this entire dictionary. Type of JSON data is dictionary. Now, from this, take the first level. Okay, I'll do that. Let's just run it. Right? So I get just the IP address, which is associated with firewall. Okay. So if you want to understand what is happening, first anyway, you have printed JSON data and type of JSON data, which happen to be, this is a dictionary, showing its type as dictionary. From this dictionary, first you want to break down the highest level, right? Highest level, this is the key. So use that key and see what comes out. Let me comment the other lines. What you got is a list of dictionaries. Right now, all you are dealing with is a list. Doesn't matter whether they are integers, whether they are floating points, whether they are strings inside the list. Right? Outside, you have a list. List, 0th element of the list is this, first element of the list is this, second element of the list is this. Right? So you get, if it's even more confusing, you can store in a variable. Device underscore list is equal to this. And now this is a list. Take this guy from this device is equal to device list of 2. Right? You can even call third device. Right? Third device is nothing but device list of 2. Why? Because indexing starts at 0. Right? Zeroth element is the first device. First element is the second device. Second element is the third device. So you got into this. Print this. Right? You've already printed the device list. Now print this. You got that specific device which happens to be a dictionary. Right? Now from this device, third device underscore IP is equal to third device of, this is a dictionary, of IP. Like this, you can break down step by step, step by step. Keep checking at every step what type of data it is, so that you'll know which operation to perform next, what kind of indexing to be used. If it is a dictionary, use string-based indexing. If it is a list, use number-based indexing. Once you are quite comfortable, conversant with working these types, you can just squeeze everything into a single line. Because by then you will know, by looking at this, you will know, okay, what you are dealing with. Till then, you don't be stingy, write as many lines as needed. At every type, at every step, you can also keep checking what type of data you're dealing with. Write operation is exactly the same. You take one big dictionary, right? You take one big dictionary and use dump method. Open the file, use dump method. You will have it ready in a file. And the example is given. You can do this as a hands-on exercise. Right? Import JSON. This is your data, which is available as a dictionary. Then you are taking the existing devices. Right? The existing devices are in a list. You are appending your this dictionary. This is a list, right? To your adding this dictionary to the existing list. Now you're opening a file with open as if json.dump data. Take the data, dump it in file. Right? While dumped, you need to give two parameters, right? What to dump, where to dump. What to dump, where to dump. Now this guy is a special listing because you see this JSON file which I've created is nicely arranged like this, right? First, every other row is indented, which is showing the nice parent-child relationship. Right? By looking at this, I can understand that, yes, devices is the only top-level element, which is a list. Inside that, you have three siblings. These are all siblings, children of devices, siblings of each other. Right? So like this. Now, this is coming because of this indentation. So if you miss this part, indent is equal to 4, it is going to write everything in a single line. So you give this indent is equal to 4 or 8 or 16, it will introduce those many spaces for every line. That's the purpose of this line, indent is equal to 4. Okay, now working with YAML files is exactly the same as JSON files. And YAML, I think we have already covered. You can take this JSON file, use any of the online converters to convert it into YAML file, right? It will just remove these curly braces. It will remove this list, introduce hyphens, right? Let's try it out. Take this. JSON to YAML. Right. This has become this, which denoting the name of the start of the file. This guy is the top level object. So the top level object, colon. Inside that you have a list. List is denoted using this hyphen. Okay. So this is how it looks. Import YAML instead of JSON, you just import YAML. Opening is the same with open. YAML file name. This is optional. Read. And if you skip it, by default it will be read as file handle. Now config data. So instead of a simple load, what YAML guys have given is they have given a safer way to load data, because nowadays people try to send malicious script through config scripts as well, right? Which will you are downloading config script from someone, config.yaml from someone, and he will introduce his own script and then try to send it as a config file. So especially YAML is used for configuration files. Many of the softwares will use YAML as their configuration file format. So there is a risk which is involved if you are downloading the third-party configurations. So to prevent such malicious things from happening, instead of a normal load, what they have given is this safe load. This safe load method, what it will do is, it will try to detect any like script calls, these kind of things, and then it will prevent them from being executed. Right? So that's the only difference between JSON and YAML. So config data is equal to YAML.safe_load. Instead of load, you call safe load, pass the file object, your data is available in config data. Right? Now YAML data is loaded into Python. Into which format? Dictionary format. Because there's a close association between YAML and JSON, and close association between JSON and Python dictionary. So the data which is read from YAML file is loaded into Python as a dictionary without you having to do anything. Once it is there, you can start accessing it as usual, as you would access any Python dictionary variable. Writing is exactly the same. You have a Python dictionary. This is a Python dictionary, right? So you open the file in write mode and simply dump. Here there is nothing like safe dump because you're writing data. It's the responsibility of the guy who is going to read your file to use safe load, right? In case he doesn't trust you, right? You are free to dump anything when virus. YAML.dump, config data, what to dump, where to dump. Write is all this dump, write, all this are like what, where. Okay, we'll stop here. Any questions? Okay. Thanks, everyone. If no questions, we can close.